In this short video on abstract classes and interfaces, I'll help you understand what these terms mean, be able to describe the differences between them, and recognize some commonly used interfaces in the Java API. Let's get started. An abstract class is one that cannot be instantiated. In other words, you can't create an object directly from it. But why have them? Abstract classes are meant to be incomplete blueprints. They can define behaviors and attributes that other more specific classes will inherit and complete. Here's the general syntax. Essentially, you just add the abstract keyword in between any visibility modifiers and the word class. So here are some practical examples. Maybe we have an abstract class about what an animal is or what a fruit is, and you can see how we might have visibility modifiers like the word public in front of. Some important notes about abstract classes. You can still use them as data types, such as in arrays or array lists, and they can contain a mix of abstract and concrete methods. So concrete is kind of the opposite of being abstract. It's the things that we've done already. And yes, abstract classes can have constructors, but you just won't directly use them with the word new. We can also use abstract classes in inheritance. A subclass can be abstract even if its superclass is concrete. Now let's think about abstract methods. So an abstract method is one that's defined in an abstract class, but it gets implemented in the subclass. So in other words, you don't have a body of the function in the abstract class. The general form is to include the word abstract in between the visibility modifiers and the return type of the method. So maybe more specifically, we might have an abstract class that has a method called makeSound. We're not defining how the sound will be made. Perhaps this is relating to animals, but we will implement that in any of the subclasses of that superclass that's abstract. Any class that contains abstract methods must be abstract itself, and if a subclass doesn't implement all of the abstract methods of a superclass, that subclass must also be abstract. In other words, the only way to get rid of the abstraction is when we actually implement the methods themselves in a concrete class that inherits from the abstract one. An interesting note here, or a fact, is that a subclass can actually override a concrete method from its parent and turn it into an abstract method, forcing further superclasses to implement it. One last important note on this slide in terms of syntax notation: the body of these methods isn't getting completed or implemented in the abstract class, so we don't have curly brackets, but we just have a semicolon to end the definition of the method itself. In terms of UML notation, the main principle we need to understand is that abstract classes and methods are italicized. So here, geometric object is an abstract class, and the getArea and getPerimeter methods are abstract methods. Those would get implemented in subclasses. So for instance, circle here is a subclass of geometric object. So it will implement those methods, but we generally don't mention those methods or list them in the UML diagram of the concrete subclass. And then I'll also point out, since this is the first time we're seeing it, the hashtag or pound symbol, remember that that's protected visibility on, in this particular case, the superclass constructors. Now, we won't go deep into this here, but Java has several built-in abstract classes. One of the most popular is the java.lang.number class. So this is abstract, including abstract methods shown in italics. And what's important here is to note that all of these other subclasses are concrete implementations of the abstract number class. So if we needed to make array lists of numeric information, we're going to use these other classes, the double, float, long, integer, and so on and so forth, to create that array list. Those are all concrete versions of the abstract number class. Now let's change gears to talk about interfaces. Interfaces in Java are like the ultra abstract class. So it's a class-like construct that only contains two things: constants and abstract methods. It doesn't contain constructors, no fields, no method bodies, at least in the traditional Java. Newer versions of Java may have default methods, but we'll stick to the basics here. In terms of the form of interfaces, we will add the word interface in between any visibility modifiers and the name of the interface. So we've got some specific examples here, like the interface comparable or editable. Important notes here: like abstract classes, we won't instantiate interfaces using the new operator. There's no constructors though, unlike the abstract class. We also don't even use the word class. Notice that class doesn't appear in the general form here. Interfaces are like abstract classes, but they define common behavior for classes, even if those other classes are unrelated. And we're going to use the word implements when a particular class adopts or uses an interface that we've designed. All properties must be public static final in an interface, and all methods must be public abstract. Let's see how this looks in UML notation. The main thing to notice here is that interfaces have this syntax at the top, kind of these angled brackets with the word interface and then the name of the interface itself. They're also italicized. Contrast that with the abstract class animal that's shown on the right here. So there are different types of animals like a tiger or a chicken. Interface here is describing a behavior of something. So a chicken or a fruit should be edible. And then each of those classes that inherits or implements that particular interface, and we notice that it's an interface because of the dashed lines, they need to implement that abstract method called how to eat. So dashed lines pointing to interfaces that are implemented in subclasses. Those subclasses could come from abstract classes like animal in this case. Let's now look at a real-world built-in interface to the Java programming language. This one's called comparable. It lives within the java.lang package, and it has exactly one method, compare to. So you'll notice a couple things here. In the angled brackets, we have the letter E. This is a generic type. So we saw this when we dealt with array lists as well. What this allows us to do is that when we implement this interface, we can specify the element type that we should be comparing something to. And then when we implement that method, we'll give as an input parameter an instance of that element type. Here's what that might look like. So the integer class, which is a constant class that extends from the abstract class number and implements the behavior from the interface comparable, where when we compare something, we want to compare integers in this particular class, and then we will override the compare to method. So what we're overriding is in the number class. We're overriding the compare to method of the comparable interface, which will now take an integer as input and do something with it, presumably compare whether one is greater than or less than the other. Another interesting type of built-in interface to Java is called the clonable interface. And this is used to specify that an object can be cloned. The most interesting part about it is that you'll notice it's empty. That's not a mistake. That's not an error. I'm not leaving out code here. There's nothing inside of the interface. So this is what's called a marker interface. And if you're wondering why this would be useful, is that this is a lightweight way to flag certain behavior. So anytime you have a class that implements clonable, you're alerting the reader of your code and Java itself that we should be able to safely clone that object using the built-in clone method of the default, root superclass java.lang.object. So to summarize, abstract classes are partially implemented blueprints that can be used as a superclass, in which case the concrete class that subclass that inherits from it or extends from it needs to implement the abstract methods in it. Interfaces define behavior that classes should have. And the nice thing about using both abstract classes and interfaces is that we can extend from an abstract class while implementing one or more interfaces that describe behavior or methods that ought to be implemented in the class itself. We should use abstract classes when there's shared implementation and use interfaces when multiple unrelated classes need to share behavior. Thanks for watching.